All right, so a complex fraction is just a fraction that has fractions in it. So a fraction that has a fraction in the numerator or denominator. So multiple fraction bars, basically. I have a couple examples just showing you one that has a fraction in the numerator. This one has a fraction in the denominator. This one has fractions in the numerator and the denominator. So they look really intimidating, but they're actually not that difficult to solve. So when we solve these, the goal is going to be to get rid of the fractions that are in the top and the bottom so that we just have one fraction instead of, 4. So we will find the least common denominator of all the rational expressions, and then we'll multiply by that in the top and the bottom of the fraction. And that will allow a lot of stuff to cancel out. So for this first one, again, if the numbers aren't fractions, you might just want to put them over ones, just as placeholders. So we're going to look at all 4 denominators, which are x, 1, y, and 1. The least common denominator between all of those things would be x, y. So we're going to multiply by x, y in the top of the fraction and the bottom of the fraction. So I'm going to multiply this by x, y, technically over 1, and that might help you. And then in the denominator, I'm also going to multiply by x, y over 1. We do have to distribute. Okay, and most of the time I won't show work for this, like I'll just cancel out the x's in my head and write a y. But for the first example, I'll show the work. So we would get xy over x plus 3xy over 1. And then in our denominator, distribute also. So we'll get 5xy over y plus 4xy over 1. And then we can cancel out our common factors. So our x's would cancel out to leave me with just y plus 3xy. In the denominator, these y's would divide out to leave me with 5x plus 4xy. And if you want to leave your answer like that, you can. You can also factor out a GCF if you'd like, because there's a chance that something could divide out. So you could take a y out of the top, and it would be 1 plus 3x. And the bottom, we can take out an x. But I would accept either of those answers as your final answer. Mr. Caroli asked that I go over these a lot, because you'll see them in pre-calc. The next one, we see fractions in the top and bottom again. You're going to compare all your denominators. Find the least common denominator, which actually is the same as the last one. It'll be x, y. So we're going to multiply by xy over 1 in the top and the bottom. And again, you might want to group that in parentheses. Now this time I'm not going to show all of the work. I'm just going to do it mentally. And hopefully you guys see what's happening. So when you multiply this, the x's would cancel to leave you just with y. When you multiply this by the second, the y's would cancel, leaving you with just an x. So I wouldn't actually cross them off because you still have to distribute that xy to the second fraction, but you can mentally cross them off. And then in the denominator, when I distribute this, the y's would divide out to leave me with 2, and our x's would, 2x. And in this one, my x's would cancel out to leave me with just a minus 1y. And that's it. If you want to rearrange it and make it x plus y or something. The next one's even easier. We really only have one denominator, and that's x. So we'll multiply by x over 1 in the top and the bottom. So these x's would divide out to leave me with just 1 in the numerator. And in the bottom, I would get xy. I want you guys to try number 4 on your own. And then we'll do 5 and 6 because they're a little bit harder. Again, I would make anything that's not a fraction into a fraction, just so you remember to only multiply your numerators. All right, the next one I think is the hardest one for our common denominator. It's just going to be the longest of the common denominators. So we compare all of them. We have x, x plus 1, x minus 1, and x plus 1. So our common denominator would be all 3 of those different things together. X, x plus 1, and x minus 1. Let's put it here. All over 1. And then same thing down here, we'll multiply by it again. Put parentheses. And we'll distribute. Now we have a binomial. So we do notice that the x's would divide out. So we would be left with x minus 2 times x plus 1 and x minus 1. So we're going to have to multiply 3 binomials together later on. Distribute this whole thing to our second. So the x plus 1s would divide out, leaving me with plus 2x times x minus 1. And then in our denominator, the x minus 1s would divide out in our first set. So I'd be left with 3x times the quantity x plus 1. And minus x plus 1's divide out, we'll have x times x minus 1. And then we just have more work than usual to simplify this out. Personally, I would probably just FOIL these first, but you could FOIL those two first, doesn't matter. But these are going to get us x squared minus 1, right? Because they have a positive 1 and a negative 1. So this would be x squared plus 0x minus 1. And then we'd have to FOIL these two things. So we will get x cubed minus x minus 2x squared plus 2. Distribute our 2x over here to get plus 2x squared minus 2x. In the denominator, we just have to distribute, so that's easy. And make sure you do distribute that negative with the x. In our second set, so that'll give us a minus x squared and a plus x. And then just clean all of that stuff up to find your final answer. So we should have x cubed minus 2x squared plus 2x squared. Those just become 0. We'll have minus x and minus 2x is minus 3x plus 2. All over 3x squared minus x squared is 2x squared plus 4x. If you want, you can factor a 2 out of the denominator, but you don't have to because nothing's going to divide out. Do you think you want to try the last one on your own? 6? Do you want me to do it? Raise your hand if you want me to do it. Okay, I'll do it. If you think you're feeling up to it, just ignore me and do it on your own. So again, first find your common denominators. So look at your fraction denominators. We only have 2 this time. And unfortunately, they're not the same. So we'll have to multiply. The common denominator will be both of them. So it'll be 2y plus 1 and 2y minus 1. Do the same thing in the bottom. And again, if you want to, you can make this 1 over 1 so that you have all fractions. And then we will start distributing. So when I distribute this whole thing, the 2y plus 1s will divide out. So I'll be left with just the 2y in the top times the 2y minus 1. And when I distribute this whole thing to here, both of those things are coming along. So that'll be minus 1 times 2y plus 1, 2y minus 1. Similar in the denominator. When we distribute this over to a 1, it just gets the whole thing. Nothing cancels out. And bring our minus sign over. Whenever I distribute this to my second set, the 2y minus 1s would divide out, so we'll have 2y times 2y plus 1. And then we just need to simplify. 4y squared minus 2y. Now for this one, I might go ahead and FOIL these first and then distribute my negative 1. So I'll just leave that negative 1 there. And when I FOIL these, I'm going to get 4y squared minus 2y plus 2y, which is 0y, so I'll just leave that off, minus 1. And then I'll distribute my negative. So I'll get a minus 4y squared and a plus 1. Minus a negative will be a positive 1. And the denominator, again, we'll FOIL those, which is the same thing as up here. So we'll get 4y squared minus 1, just like we have in the top. And we'll distribute a negative 2y to get a minus 4y squared and a minus 2y. And then we just clean up our tops and bottoms. So the 4y squared minus 4y squared is nothing, so we'll get negative 2y plus 1. And in the denominator, we'll get negative 1 minus 2y. And I would accept that as a final answer. You could factor out a negative 1 in the top and the bottom if you wanted to, which will get you 2y minus 1. And if I factor out a negative 1 in the bottom, I would get 1 plus 2y. And then our negatives will cancel out, so I'd be left with 2y minus 1 over 2y plus 1. And the only reason I'm showing you that is that on your answer key, a lot of times they do that. So in case you get a final answer, and yours is like this and theirs is like this, hopefully you can realize they're the same thing. All right, try the closure. We're here till 8:16, I think. Multiple choice, and this one should be a little bit easier because it only has an x in the denominator.